Hey everyone, welcome back to the channel. Have you ever been caught in a sudden downpour and wondered, where does all this water actually come from? It feels like it just appears out of nowhere, right? Well, today we're going to unravel the amazing science behind rain. It's a journey that takes us from the ground, high up into the sky, and back down again. So, grab a cozy drink, and let's dive into the fascinating process of how rain is formed. It all starts with a process you've probably heard of: evaporation. The sun is the giant engine that powers our planet's weather. And it plays the starring role here. When the sun shines on bodies of water like oceans, lakes, and rivers, it heats them up. This heat gives the water molecules at the surface enough energy to break free and escape into the air as a gas. We call this gas water vapor. But it's not just big bodies of water. Evaporation also happens from the soil, and even from plants in a process called transpiration. Think of it as plants breathing out water vapor. All this invisible water vapor rises up into the atmosphere. So now we have all this water vapor floating around in the air. What happens next? Well, as you go higher up in the atmosphere, the air gets colder. As the warm, moist air rises, it starts to cool down. This cooling causes the water vapor to change back into tiny, microscopic liquid water droplets. This process is called condensation. It's the exact same thing you see when you take a cold can of soda out on a warm day and little water droplets form on the outside. The cold can cools the air on it, and the water vapor in that air condenses into liquid water. In the sky, these tiny water droplets need something to cling onto. They can't just form out of thin air. They need a surface. These surfaces are tiny particles floating in the atmosphere, like dust, salt from the ocean spray, pollen, or even microscopic bits of pollution. Scientists call these particles condensation nuclei. So, the water vapor condenses onto these tiny particles, forming little cloud droplets. When billions and billions of these droplets come together, they create something we can see: a cloud. So, every time you look up and see a fluffy white cloud, you're actually looking at a massive collection of tiny water droplets or ice crystals, all clinging to invisible specks of dust and salt. But a cloud full of tiny droplets isn't enough to make it rain. These initial cloud droplets are incredibly small and light, so light that they can just float around in the air currents within the cloud. For rain to happen, these droplets need to get much, much bigger and heavier, and this happens through a process called coalescence. Imagine a massive, chaotic bumper car rink in the sky. The little cloud droplets are constantly moving around, bumping into each other, and merging. When two droplets collide, they stick together to form a bigger droplet. This new, larger droplet then collides with more droplets, growing bigger and bigger still. This process continues, with droplets merging and growing, a bit like a snowball rolling downhill. It takes about 1 million of those tiny original cloud droplets to combine and form a single, average-sized raindrop. Once a droplet becomes heavy enough that the upward air currents inside the cloud can no longer hold it up, gravity takes over. The droplet begins to fall towards the earth. And when millions of these heavy droplets start falling from the clouds, we call it rain. Now, there's another interesting way rain can form, especially in colder climates or at higher altitudes where the clouds are above the freezing point. This involves ice crystals. In these colder clouds, you have a mix of super cooled water droplets, water that is still liquid even though it is below freezing, and tiny ice crystals. For reasons related to vapor pressure, water vapor is more attracted to the ice crystals than it is to the water droplets. So, the water vapor leaves the droplets and deposits directly onto the ice crystals, making them grow larger. This process is called the Bergeron process. These ice crystals become heavy, start to fall, and often collide and stick with other ice crystals or supercooled droplets, forming snowflakes. As these snowflakes fall through the cloud and into warmer layers of air below, they melt and turn into raindrops. So, believe it or not, a lot of the rain that falls, even on a warm summer day, might have actually started its journey from the cloud as a snowflake or an ice crystal. It just melted on its way down to you. The type of precipitation we get, whether it's rain, snow, sleet, or hail, all depends on the temperature profile of the atmosphere it falls through. If the air is warm all the way down, you get rain. If it stays freezing all the way to the ground, you get snow. So let's recap this incredible journey. It's a continuous cycle, often called the water cycle. The sun's energy causes water to evaporate from the Earth's surface, turning into water vapor. This moist air rises and cools, causing the water vapor to condense onto tiny particles to form clouds. Inside the clouds, these tiny droplets collide and grow until they are heavy enough to fall as rain, or they grow as ice crystals that melt on their way down. The rain then falls back to Earth, filling up the oceans, lakes, and rivers, watering the plants. And the whole cycle starts all over again. It's a perfect, self-sustaining system that has been happening for billions of years, and it's essential for all life on our planet. The next time you're walking in the rain, or just watching it from your window, take a moment to think about the amazing journey each one of those raindrops has taken. From the surface of an ocean thousands of miles away, up into the high atmosphere to form a cloud, and then all the way back down to you. It's a beautiful and powerful reminder of how interconnected everything is on our planet. It's not just water falling from the sky, it's a vital part of a global system that makes our world a living, breathing place. Thank you so much for joining me on this deep dive into the science of rain. I hope you found it as fascinating as I do. If you enjoyed this video and learned something new, please give it a thumbs up. And don't forget to subscribe to the channel for more science explorations. Let me know in the comments what weather phenomenon you'd like me to cover next. Until then, stay curious.